Okay, so we're going to take a look now at what are called special right triangles. There are two special right triangles that we like. They show up very commonly in the real world, and so we gave special definitions to them. So we're going to start off with the first one. It's called a 45, 45, 90, and it's called a 45, 45, 90 because those are the three angles, okay, of this right triangle. They are both 45-degree angles, and then because it's a right triangle, the third one will be 90, okay? And so here's the rule, the special kind of relationship that happens in 45, 45, 90s. Okay, what they're saying is that the two legs are going to be the same measure, and that's true just because a 45, 45, 90 is an isosceles triangle. If you remember the isosceles triangle rules, we said that across from equal angles will be equal sides. So if I travel through from the 45 to its side, and I travel from the other 45 to its side, that those should be the same. And so in this definition, they're calling those sides S, right? So both legs will be congruent, and the hypotenuse will always be the square root of 2 times the leg. So for example, here's a simple one. If I called this 6, okay, then this other leg would also have to be 6, okay? And that would make the hypotenuse just 6 times the square root of 2, which we're not even going to multiply out. We'll just leave it as 6 square root of 2, right? And that would be my problem there, right? So let's kind of apply this and see what we mean by using when we use this property, okay? So this example is a 45, 45, 90, so you want to recognize that kind of when it's mixed in with other problems. And so I'd take a look at this and say, okay, 45, okay, across from the other 45, this one would also have to be 9, so we'll add some additional information. And they're asking about the hypotenuse. So just to get used to this, I'm just going to have you write down the rule and say, if I do the leg times the square root of 2, that's going to give me the hypotenuse. And so if I fill in what I know, 9 is a leg, okay, times the square root of 2, and my hypotenuse is what they called h. So I would actually just call h 9 square root of 2. Right, so no Pythagorean theorem, no any kind of special calculation necessary. You're just going to plug into the formula and simplify. Right, so if I come to this example, it's really the same setup. I'm going to say leg times the square root of 2 is equal to hypotenuse. Hypotenuse is what they called x, okay, and they're calling their leg 2 square root of 2 times the square root of 2. So now I just got to simplify this. The square root of 2 times the square root of 2 is 2. So these two together are just 2. So this is 2 times 2, which is 4, right? So you might get these kind of funny looking examples where you have to multiply some radicals together, but as long as you go with the basics of writing down the rule, plugging in what you know, and simplifying, they'll be pretty straightforward. Okay, so here's another example, maybe a little bit less straightforward. Right, so in this example, they're giving us the hypotenuse. So let's write down, okay, the rule. The rule, because this is 45, 45, 90, says leg times the square root of 2 is the hypotenuse. Okay, so I'm going to plug in what I know, and in this case, I know that the hypotenuse is 6. I don't know the leg, but they called the leg x. Okay, so this is my rule now. So now I got to do a little bit more work. I have to solve for x, which is going to be done by dividing away this square root of 2. Right, and so I'm going to say x is equal to 6 over the square root of 2, but just generally, we've kind of come to the agreement that we don't want radicals to show up in the denominator. We don't count them as simplified if there's a square root in the bottom of a fraction. So we had a way in Algebra 1 back to when we learned about radicals and all the properties to fix this, and we said, if I want to get rid of a square root of 2 in the denominator, I can multiply it by itself. The square root of 2 times the square root of 2 is just 2, because multiplying a radical by itself just gets rid of the radical, okay? But we know just from way back when you learned about fractions that if you multiply the bottom of the fraction by something, you need to multiply the top by the same thing. And so I'm going to say this is just 6 times the square root of 2, which is just 6 times the square root of 2. I can't multiply a radical by a non-radical, right? And so this is my answer. It fixes the problem of having the radical in the denominator, and we can do a little bit more simplifying now. This says 6 over 2, which is a fraction. 6 over 2 is just 3. Right? So I can turn this into 3 square root of 2. Right? So we have these problems where we might have to rationalize the denominator because we're using radicals, and that's just kind of a convention that we use when we're doing radicals. Okay? So let's take a look at one more example that kind of applying 45, 45, 90s, and that's a problem that actually involves a square or a diamond, right? A diamond's really a square just turned on its side, okay? So if I'm looking at a softball diamond, on a softball field, the bases are all 60 feet apart, right? So if this is kind of home plate down here, it would be 60 feet to get to first base, 60 feet to get to second base, 60 to third, 60 to, right, to get back home. So what they're wondering is if the catcher who sits here at home plate throws a ball directly to second base, right, follows this straight line, how many or how far is that, right? And so here's what happens, right? On a baseball diamond, these are all right angles all the way around, right? And so we know one of the properties of a square is that when you draw a diagonal into a square, you actually create 45-degree angles when you draw in that that diagonal. So these are going to be 45, okay, and 45 all the way around. Okay, that's a rhombus property. And I can kind of focus now on this little right triangle, which is a 45, 45, 90. We know one of the legs, right? So I can say leg times the square root of 2 is equal to hypotenuse. And the diagonal of this right triangle is, the diagonal of this square is the hypotenuse of the right triangle. So I'm going to plug in and say 60 times the square root of 2 is equal to d, right? And so since they asked us to do this to the nearest foot, okay, we're going to turn this into non-radical form. So let me bring up my calculator, okay? And we're going to type in 60, okay, I'm not on my calculator here. You can see it, but I can't. Okay, so 60 times the square root of 2. So let me do 2 square root, okay? And if I multiply this out, it comes out to be about 84.8. So if we round properly, that's about 85 feet. So we'd say D is approximately 85 feet, okay? So this is kind of an application where anytime there's a square with a diagonal, we're actually creating a 45, 45, 90 right triangle, and we can very easily find the diagonal by using 45, 45, 90 rules, which says leg times the square root of 2 is equal to the hypotenuse.